Hello and welcome. We are looking at the topic of atoms and radiation, and in particular we're going to look at something called background radiation. Now by radiation, or radioactivity is it sometimes called, or nuclear radiation, we need to understand what that actually means, and I'm going to use the example of a substance called uranium, which is an element, and it has isotopes that are radioactive to varying degrees. So if I was to look at some uranium, I could take out one of the atoms, expand it, and it would look a little something like that. We've done quite a lot of work on atoms and atomic structure. I'm not going to fill out the details of all the electrons, protons and so on. What we're going to look at is the idea that we've got a nucleus here, we've got the electron shells, and this substance uranium that's giving out radioactivity is giving it out from the nucleus. Okay, it's a very important point to remember. Radiation or radioactivity comes from the nucleus of the elements which it is coming from. Okay, so it can come out in one of three forms. It can either be gamma radiation, sometimes we have alpha particles, and sometimes we have beta particles, and we're going to look at these in more detail in another video. But for the moment, it's important to remember that when we're talking about radioactivity, we're either talking about energy or particles coming from the nucleus of the atoms in question. Okay, so how do we actually measure this? Well, we have a kind of instrument called a Geiger tube, or sometimes called a Geiger-Müller tube, and what that does is it measures the amount of radioactivity coming from a substance, and it measures it in counts per minute. So every time it measures an amount of radioactivity, it increases the count, and the faster the count rises, or the higher the count, the more radioactive the sample is. So here's our sample giving off radioactivity. It's important to remember that it will give up or give out radiation no matter what you do to it. So if you heat it or cool it or break it or smash it or powder it, whatever you do, it's still going to give out this radioactivity. Okay, so that's how we measure it, and a couple of important points about the nature of the substance. The last thing I want to really talk about, and that's the main topic of the video, is that background radiation is radiation that is present naturally, and it comes from the environment. And there are various sources of background radiation, and you should be aware of what those different sources are. We have background radiation coming from the air, and in particular there's a substance called radon gas that's in the air, and about 50% of background radiation comes from this substance. Some of it comes from food and drink. It can also come from rocks or the ground, and if we use those kind of rocks for building materials, then it's going to come from buildings. It comes from cosmic rays, which are from outer space, and it also comes from man-made sources such as nuclear weapons tests, nuclear accidents, some from air travel, nuclear reactors, and some from medical sources as well. So for example, X-rays or X-ray tubes that produce these X-rays produce this background radiation as well. Another thing to remember is that it's in low amounts, so it tends to be harmless. It can be in higher amounts in some areas than others, depending on the type of rock or the type of environment that you're in, but background radiation is always there. It's there in low amounts, and it's found either naturally or from man-made substances. Okay, so you basically need to be aware of that, the different types of sources, what background radiation is, and in fact what we mean by radiation or nuclear radiation. Thanks for watching, and I'll see you in the next video.